Hi, this is Discrete Structures. This is the homework for section 1.6, which is about sequences. Here's the homework problems. The problems are fairly easy. Lots of calculations, nothing intelligent. But you got to do it, and you got to have it on your fingertips, not in your head. It's simple. Okay, so let's do it. Okay, number 1A. 1A. Okay, 7 factorial divided by 5 factorial. This is 7 times 6 times 4 times 5 times 4. So this is basically 7 times 6 times 5 factorial divided by 5 factorial. This cancels out with this. 7 times 6 is 42. Okay, next. E, the sum, so this is E, the sum of k equals 0 to 5 of k factorial. So let's do this. So this is equal to 0 factorial plus 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial. So this is 1 plus 1 plus 2, 2 times 1 is 2, plus 6 plus 6 times 4 is 24, plus 24 times 5 is 120. I think it's 120. We need a calculator. By the way, this is not a hard thing, but a calculator is helpful. So we go to the calculator and we type in 5 factorial and we get 120. So altogether this is equal to 2, 4, 10. So this is 34. 34 and 120 is 154. Great. Next, the pi from 3 to 6. Okay, F is the product of k equals 3 till 6 of k. Sorry, I did it with j. They did it with j. So j. So this is equal to 3 times 4 times 5 times 6. 6 times 5 is 30. 3 times 4 is 12. 12 times 30 is 10 times 30 is 300, and 2 times 30 is 60, so this is 360. Okay, great. Next, lots of things. Okay, so let's erase. 3a, the sum of 1 to n with 3. So this is 3a. The sum, k equals 1 to n of 3 to the k, and they want you to do where n is equal to 1. So where n is equal to 1, this becomes from 1 to 1, so this becomes 3 to the 1, which is equal to 3. For n is equal to 2, this becomes 3 to the 1 plus 3 to the 2, so that's equal to 3 plus 9, which is 12. For n is equal to 3, this becomes 3 to the 1 plus 3 to the 2 plus 3 to the 3, so this is 12. Plus 9 is 12 plus 3 to the 3. 3 to the 3 is, so this is equal to 12 plus 3 to the 3 is 3 times 3 is 9 times 3 is 27 plus 27. So that's equal to 39. Okay, last one. For the fourth, for n is equal to 4, this is equal to, let's do this, 3 to the 1 plus 3 to the 2 plus 3 to the 3 plus 3 to the 4, which is equal to 39, that's this, plus 3 to the 4. 3 to the 4 is 3 times 3 is 9. 3 times 3 is 9. So it's 9 times 9 is 81. So plus 81. 81 is, so, all right, 3 and 8 is 11, is 120. Okay, sounds good. Next, 3b. 3 to the n. Okay, oh, 3 to the k. 3 to the k, we did that right. Okay, good. Next. Okay, 3b is equal to the sum from 3 to the n, from the sum of k equals 3 till n of, don't move, k to the 3. K to the 3. Okay, so they want you to do this for n is equal to 3. It can't be lower than 3 because you start at 3, so when should you finish? N is equal to 4 and n is equal to 5. That's what they want us to do. Okay, so let's do that. So this is equal to 3 to the third. 3 to the third. That's just that because we stop at 3. So 3 to the third is 3 times 3 is 9 times 3 is 27. So that's 27. To the fourth is 3 to the third plus 4 to the third. Okay, so that's equal to 27 plus, what's 4 to the third? 4 times 4 is 16 times 4 is 64, so that's 64. Okay, 27 plus 64 is 80, 91. Okay, 5 is 3 to the third plus 4 to the third plus 5 to the third. What's 5 to the third? Hold on, let's do this. 3 to the third plus 4 to the third is equal to 91, plus 5 to the third is 5 times 5 is 25, times 5 is 125. So it's 125. So this is going to equal to 206, 9 and 2, 2 and 1 is 3, 236. Nope, that doesn't make sense. Yeah. Nope, that doesn't make sense. Let's do that again. 91. Okay, 6, 2, no, that's a 1. So it's, I'm sorry, 216. Okay, that takes care of that. So that's 216. Next. Okay, 3. That's it, we did 3b. Now 4a, b, and c. So let's do 4a. Calculate 4a from 1 to 10 of minus 1 to the j. So j is equal to 1 to 10 of minus 1 to the jth power. Okay, so let's do this. This is equal to minus 1, because that's even, plus 1. Okay, plus minus 1, because it's odd. So this is odd, 1, 2, 3, plus 1, plus minus 1, plus 1, plus minus 1. 1, 2, 3, 4, 5, 6, 7, plus 1, plus minus 1. Plus 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's do this, add this up. That's 0, 0, 0, 0, 0. So it's equal to 0. Can't get easier than that. 4b, from 0 to 3 of k squared plus 1. So k equals 0 to 3 of k squared plus 1. So this is equal to 0 squared plus 1 plus 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1. Okay, this is equal to 1. 1 squared is 1 plus 2 plus 5 plus, I think I did this in class actually, this is 10. So this is 10 plus 5 is 15, 17, 18. So this is 18. So I must have stolen this problem from the book. Next, they just want to show you the difference between this and the next one. So what's this? The sum of k equals 0 till 3 of k squared parentheses plus 1. Okay, so they want to show you what this parentheses. This parentheses means do each one of these with a plus 1. Now this parentheses means do this and then do a plus 1. So this is going to equal to 0 squared plus 1 squared plus 2 squared plus 3 squared, all that, and then plus 1. So this is equal to 0 plus 1 plus 4 plus 9 plus 1. So this is 14 plus 1 is 15. Okay, 15 is not 18. Okay, that takes care of that. Next problem is number 7. 7. Consider the sequence. I actually mentioned this in class that we were going to do this, but so let's do it. Consider the sequence given by a of n is equal to n minus 1 divided by n plus 1. Okay, for n is a member of P, not 0. So we don't have to, we start at 1. List the first six terms of this sequence. Okay, so let's do it. So a of 1 is equal to 1 minus 1 is 0 over 1 plus 1 is 2. So that's equal to 0. A2 is equal to 2 minus 1 is 1 over 3. A3 is equal to 2 over 4, which is equal to a half. Okay, A4 is equal to 3 over 5. A5 is equal to 4 over 6. That's 2/3. And A6 is equal to 5 over 7. Okay, sounds good. Next, calculate a of n plus 1 minus a of n for n equals 1, 2, and 3. Okay, so let's do this. So so we're doing B. Okay, so first, 1/3 minus 0. So A2 minus A1 is equal to 1/3. A3 minus A2, okay, so this is n is equal to 1. This is n is equal to 2. A3 minus A2 is what? It's equal to a half minus a third. What's a half minus a third? So these are, let's make this 6 and 6. Okay, so this is going to be 3, and this is going to be, so that's 3/6 is another way of saying a half, and 2/3 is another, 1/3 is another way of saying 2/6. So you're going to subtract that, you're going to get 1/6. Very nice. Now n is equal to 3. Okay, and so we're going to talk about A4 minus A3. So A4 is 3 over 5 minus 1 over 2. 1 over 2. Okay, let's put that over 10, both of them over 10. So this is going to be 6 over 10 minus 5 over 10. And so that's going to equal to 1 over 10. Okay, notice a pattern here, 1 over 3, 1 over 6, 1 over 10. Okay, great. Now, next, show that a of n plus 1 minus a of n is equal to 2 times n plus 1 times n plus 1 times n over 2. Okay? Okay, so this is a little bit ugly math, but you got to do it every once in a while. So let's do it. So they want to show that a of n plus 1 minus a of n is equal to 2 over n plus 1, 2 over n plus 1 times n plus 2. Okay, so, and they want us to show that this is true for all n. So, let's do it. So let's just think what a of n plus 1 is. A of n plus 1 is, this is n plus 1 minus 1, that's n, divided by, we'll fix it in a second, n plus 1 plus 1, plus 1 plus 1. We'll fix that in a second. Minus, what is this? This is n plus 1 divided by, I'm sorry, that's a minus, n minus 1 divided by n plus 1. Minus 1 divided by, okay, so good. So let's fix this up. This, we're going to fix, well, let's fix this. Let's write it like this. N plus 1 minus 1 is n. This is n plus 2. Okay, minus n minus 1 divided by n plus 1. Okay, so we have a subtraction of two fractions with two different things on the bottom. So let's make it common denominators. So we're going to multiply this by n plus 1, and this is n plus 1, and this is divided by, this is n times n plus 2, minus, so this is missing an n plus 1. If you want to add these two, this is missing an n plus 1. You can't just do it at the bottom, you got to do it to the top. Okay, and this is missing an n plus 2. You can't just do it at the bottom, you have to do it on the top too. So this becomes n plus 2 divided by n plus 2. Okay, that's 1. N plus 1. Okay, n minus 1. Okay, great. Let's just put this in parentheses. Okay, so what is this equal to? On the bottom, you have n plus 1 times n plus 2. They're the same. Okay, and by the way, that's exactly what we wanted here. Now just let's multiply this out and multiply this out and hope that the answer is 2. Let's pray. You ready? So this becomes n squared plus n. N times n is n squared plus n minus, okay, what's this? N plus 2 times n minus 1. So let's multiply it out. N squared, that's n times n, plus 2n minus n, so it's plus n, plus 2 times minus 1 is minus 1, minus 2. Okay, and now we simply subtract. N squared minus n squared. That goes out with that, no problem. N goes out with that. Minus minus 2 is 2. So you're left with 2 divided by n plus 1 times n plus 2. I'm sorry, that might have looked a little bit painful. That's the benefits of YouTube. You can stop it and go back, etc., at any point. But the main point is, there was no brains here. You put in this definition, you put in this definition, You write out what exactly it is. It becomes a subtraction problem. You have unequal fractions. You make them equal, multiply everything, and you get it. Sounds good. Next. Number 8. Okay, you ready? Consider the sequence Bn, this is number 8. Consider the sequence Bn is equal to a half times 1 plus minus 1 to the n. List the first 7 terms of this sequence. Okay, so let's try it. Ready? Let's try 0. B of 0 is equal to a half 1 plus minus 1 to the 0. Minus 1 to the 0 is 1, so this becomes 2. Okay, so minus 1 to the 0 is positive 1. 1 plus 1 is 2, so you have 2. So a half times 2 is 1. B1 is equal to, let's go through it, 1 plus minus 1 to the 1, so that's minus 1, so 1 plus minus 1 is 0, so that's going to be a half times 0, which is equal to 0. B2 is equal to a half times, let's do it again, 1 plus minus 1 to the 2, that's a square. Minus 1 to the 2 is positive, so is positive 1, so this becomes 2. A half times 2 is 1. Okay, basically the only thing that changes is whether this is even or odd. So for B3, this becomes odd, and so this becomes 1 plus odd is 1 plus minus 1, and so this becomes 0. B4, it's even, so it's 1. B5, it's odd, so it's 0. B6, it's 1. Very good. Okay. Second part of the question, what is the set of values? Set of values. Set of values. It only can output 0 or 1. That's it. Okay. Next, number 10. We're up to number 10. Number 10. For n is equal to 1, 2, 3, let SSQ. Okay, we're running out of ink, so let's try this one. SSQ. I'll tell you what it stands for in a second. Of n equals the sum from 1 to n of I squared. The sum, I equal 1 to n of I squared. So SSQ stands for sum of squares. Sum of squares. Okay, great. Calculate SSQ for 1, 2, 3, and 5. So n is equal to 1. So this becomes, ready? 1 squared, which is 1. N is equal to 2. So this becomes 1 squared plus 2 squared, which is equal to 1 plus 4, which is 5. N is equal to 3, which is equal to 1 squared plus 2 squared plus 3 squared. Okay, which is equal to 5 plus 3 squared. What's 3 squared? 9, which is equal to 14. Okay, n is equal to 5. What do we do there? Okay, very simple. So this becomes 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. So this is 14 plus 4 squared, 4 times 4 is 16, plus 25. Okay, and so this becomes 30 plus 25 is 55. Period. Okay, next part of the question. observe that SSQ n plus 1 is equal to SSQ. Okay, so let's stop this for a second. Okay. SSQ, the sum of squares of n plus 1, is equal to SSQ for n. So this says add up all the numbers, square numbers from 1 till n plus 1. This says add up all the square numbers from 1 till n. So if you want to do all the numbers from 1 till n plus 1, add up all the numbers from 1 till n, and then add the number n plus 1 squared. That's it. You know what? Let's write this like this. So this is equal to the sum I equal 1 to n plus 1 of I squared. This is equal to the sum of I equal 1 till n of I squared. Hold on. Here you go till n. Here you go to n plus 1. So manually add it in. Okay? So this becomes n plus 1 squared. No problem. Okay? So let me just say that for computer science people, if you have a loop that goes from 1 to n plus 1, you can also do the same loop from 1 to n, and then after the loop, when the loop is finished, just do the last term. No problem. Okay, so we observed that. Now, last question in part 10. It turns out that SSQ of 73, let's erase this. SSQ of 73, I don't know, somebody calculated this, is equal to 132, 349. Great. Okay. Now, use this to calculate SSQ4 and SSQ2. So let's do this. SSQ 74 is equal to SSQ of 73 plus 74 squared. Okay, we're going to do this with a calculator in 1 second. Okay, well, let's do it right now. So this is 132,349 plus, let's see what 74 squared is. 74 squared is 5,476. Let's add that together. You get 9 and 6 is 5. Carry the 1. That's 12. Carry the 1. That's 8, 7, 3, 1. Very good. Okay. Now they want us to calculate. Okay, so that's the answer to that. Okay. And now they want us to calculate 72. Okay, so let's do this. How would you do SSQ, sum of squares of 72? Well, it's equal to the sum of squares of 73, but take out the last sum. This says add up all the numbers 1 squared plus 2 squared plus 3 squared plus 4 plus 70 squared plus 71 squared plus 72 squared. This says adds up all the numbers 1 squared plus 2 squared plus 3 squared plus 71 plus 72 plus 71 squared plus 72 squared plus 73 squared. The last thing we did was add that 73 squared. Subtract it, minus 73 squared. Okay, so let's do this. This is equal to 132,349 minus the last one, which was 73 squared. Okay, so let's calculate what 73 squared. Thank God we have a calculator. 73 times 73 is 5,329. Okay, and I'm now going to track them. So this becomes 132,349, that's what they told us, minus 5,329 equals 127,020. Clear. Good. Next. That's number 10. Okay, 13 and 14 are things you need to know with a calculator. You have to do it with a calculator, but better than a calculator would be doing it with Excel. So let's just, I did it with a calculator. I did it with Excel actually, so let's do it. I'm just going to give you the answers. For 13, it's n to the 4, 4n. N to the 20, 20 to the n. N factorial. This is number 13. Okay? And the inputs are 5, 10, 25, 50. Okay? You are going to see such problems in analysis of algorithms. Anyways, you got to plug in these numbers. Okay? Because you want to see how these numbers behave, how big these numbers get. So I'm going to give you the answers. I strongly recommend you stop doing it and go find your own numbers and do this. This is a very easy problem to make up and to do in the book. Okay, so it's a nice test question. So let's do this. This is 625. This is 10,000. This is 3.91 times 10 to the 5th. This is 6,250,000. So that's 6,250,000. This is 1024. This is 1048576. This is 1.125 times 10 to the 15th. This is 1.27 times 10 to the 30th. Okay, this is 9.54 times 10 to the 13th. This is 1.0 times 10 to the 20, I think. I can't read my handwriting. This is 9.09 times 10 to the 27th. This is 9.5 times 10 to the 33. Okay. Next, this is 3.2 times 10 to the 6. This is 1.02 times 10 to the 13th. This is 3.35 times 10 to the 32th. This is 1.12 times 10 to the 65th. Okay, next, this is 120. We did that. 5 factorial is 120. We just did that 5 minutes ago. 3.63 times 10 to the 6th. This is 1.55 times 10 to the 25. And this is 3.04 times 10 to the 64. Okay, it's all calculator, but again, what you should really do it is on Excel. You just have to do this and then copy and paste, and you get it in Excel. It's quite pretty. Excel is a very important function to do. Okay, the book then asks you to discuss the apparent relative growth of these functions. Okay, so I just want to tell you. You ready? Polynomials, this is a polynomial, this is a polynomial. Polynomials are the smaller things. So it's going to be n to the 4th is smaller, but and n to the 20th is a little bit larger than that. Okay, but the next highest thing is exponentials. Exponential, so this exponential and this exponential are, nope, I think that's a 20 to the n. Sorry, that's a 20 to the n. So raising things 4 to the nth power as opposed to 20 to the n power, so 4 to the n power is higher, is smaller, so that's an exponential. Sorry, 4 to the n. Okay, and 20 to the n grows even higher. Okay, n factorial is an even higher, worse than that, but for large inputs. So this is n factorial. Okay, the way to see this is, what's the difference between this and this? Why is this function faster than this? So let's take the number, because this is going to be n times n minus 1 times n minus 2 times n minus 3 times 5 times 4 times 3 times 2 times 1. This, that's n factorial. This is going to be 20 times 20 times 20 times 20 times times 20 times 20 times 20 times 20 times 20. Okay, now when you have large numbers, much greater than 20, like these numbers, okay, then these things are going to grow much bigger. Not 25, maybe 50. These things are going to grow much bigger. So the factorial grows faster because this number is going to be a lot bigger than 20. This number is going to be a lot bigger than 20. This number is going to be a lot bigger than 20, etc., etc. So you're going to have n numbers multiplied, but most of them are going to be larger than 20. So that's when it grows bigger. Okay, great. That's 13a. I did 13b also. Great. Let's do the next one. Okay. Again, it's just calculations, nothing intelligent here. N is equal to 50, 100, 10 to the 4th, so that's 0, 0, 0, 0, that's 10,000, okay, and 10 to the 6th, which is 1,000,000. Okay, and that goes there, and we make this chart. This is log base 10 of n. Your calculator might only have log base e, square root of n, 20 times, instead of writing n to the 4th root, I'm going to write n to the 1 over 4. Okay? And instead of writing, and we're going to do that again, n to the 1 over 4 times log base 10 of n. Okay, now we plug in the numbers. And again, the right way to do this is with Excel, or even just writing a program. You can write a quick Java program and plug in these numbers and then print out the outputs. So let's do this. This is 1.7. This is 2. How much do you have to raise 10 to in order to get 100? And the answer is 2. This is 4. This is 6. This is 7.07. Just think about it. 7 times 7 is 49. So a little bit more will give you 50. Okay? Square root of 100 is 10. 10 times 10 is 100. The square root of 10,000 is 100. 100 times 100 is 10,000. And this is 1,000,000 is 1,000 times 1,000. Sorry. 1,000,000 is 1,000 times 1,000. So the square root of 1,000,000 is 1,000. Next, this is 53.18. This is 63.245. This is 200. This is 632.45. This is 4.52. This is 6.32. This is 40. I bet you we can calculate that. Yeah, let's do it. Ready? Let's see if we can calculate this. Okay? What do you have to raise? I'm sorry. 10 to the 4th power. 10 to the 4th power is you have 4 zeros, is 10,000. So 10,000, the cube root is 10. So that's 10. And log base 10 of how many zeros you have is 4. So you're going to have 4. So it's 4 times 10 is 40. So that's not hard to calculate. And this is 189.7. That's for that. Okay, great. Now, let's talk about these functions. You ready? Logarithm is the slowest. Logarithm base 10 of n, that's slower than any polynomial. Okay. Now, another way for n is, this is n to the 4th. I'm sorry. Shoot. This is n to the 4th. Square root of n is n to the half. Okay. Now, you're going to learn in analysis of algorithms, leading coefficients like that, those are unimportant. So you're going to have n to the 4th is a smaller polynomial than n to the squared. So you're going to have like this, n to the 4th power. Okay, we'll multiply it by 20, but that's not really important. Okay, great. Now, the next thing is n to the 4th, with this very, very slow thing, it grows slower than that. So this becomes, the next thing is n to the 4th times log base 10 of n. And the next thing is n to the half, square root of n. So these are functions that actually grow very, very slow. And that's it. Okay. Hope you enjoyed. Again, this whole section was a musical interlude, but they're very easy questions to ask for test, and they're things that show up all the time. These types of things show up all the time in analysis of algorithms, especially the first 2 or 3 weeks of analysis of algorithms. If you want to watch more about that, watch chapter 3 of my class in analysis of algorithms. There's a video, and I promise you'll enjoy it. Take care. Have a great day.